Hi everyone, today I'll discuss one question from GATE 2022 Chemistry, question number 57. The question is the difference between the number of Gauss-Button interaction present in P and Q. So two structure P and Q they have given. So P is basically your cis-decalin and Q is basically your trans-decalin. Okay, so before going to the decalin system, first thing you should know is that what is the butane and what is the Gauss-Button interaction. So here I have shown the butane, that is this one. Okay, and here I have shown the Gauss form of butane. So how interaction will come? So here will be one hydrogen. Okay, here will be one hydrogen. So this bonding electron versus this bonding electron. So this repulsion between these bonding electrons, this molecule is slightly unstable, and this is called your torsional strain or Gauss-Button interaction. So how it works in your cyclohexane system? So typically these two example I have taken. So first one is methyl is above to the plane. So in the chair conformation I have drawn, this is axial, that is above to the plane. Okay, so now I'll do the marking 1 2 3 4 5 6 7. As in the chair conformation, that the Gauss-Button interaction and will be your on-3 diaxial interaction. So you need to find out the on-3 diaxial interaction present or not. So here will be 1 H, here will be 1 H, and here that means here on-3 diaxial interaction present. So here will be 2 on-3 diaxial interaction, that is C1, C2, C3, C4, and C1, C2, C7, and C6. But in this molecule, that is CH3 present at 0 position, that is in the chair conformation, it will be equatorial side. So there will be no Gauss-Button interaction. Okay, so now we are moving towards the decalin system. Why? Because fusion of two cyclohexane ring will give you the decalin system. So these two decalin system, that is this one is trans one. So and now for simplicity I'll start the numbering. So 1 2 3 4 5 6 7 8 9 10 11. Okay, so now you need to find out the 1,3 diaxial interaction present or not. So here will be axial hydrogen, so here will be one diaxial interaction. So on Gauss-Button interaction already we found. So here will be another, so and here will be another, and here will be another. So now this one will be C1, C2, C3, C4 on Gauss-Button interaction, then C1, C2, C7, C6, second Gauss-Button interaction. Third one will be your C1, C2, C11, C10, and C1, C2, C7, and C8. So 3 4. So in the trans conformation, that is trans-decalin, 4 Gauss-Button interaction present. Now we are moving towards cis-decalin, that is number one. I will start from here 1 2 3 4 5 6 7 8 9 10 11. Now you need to find out the on-3 diaxial interaction. So one will be this one, this one hydrogen, one will be this one hydrogen, and here will be one hydrogen, this will be diaxial interaction. Also it will interact with this carbon, and here will be one hydrogen that will also repels by this CH2 group. So C1, C2, C3, C4 will be one Gauss-Between interaction, then C1, C2, C7 and C6 will be second Gauss-Between interaction, and then your C10, C11, C2 and C3 will be third Gauss-Between interaction, and your C8, C7, okay, C8, C7, C6, okay, and C5 will be your another Gauss-Between interaction, and lastly you have that C8, C7, C2 and C3, which is finally fifth Gauss-Between interaction. So in the cis-decalane, five Gauss-Between interaction present. So the difference will be 1. So this was a question. They asked the difference of Gauss-Between interaction between P and Q. So answer will be 1. So to read further, you go through this NPTEL NPTEL lecture video, Stereochemistry by Professor Amit Vasak, Department of Chemistry, IIT Kharagpur. Thank you.